Hello, welcome back. This is a video over section 4.3, and we're going to be talking about properties of logarithms. So we've got a couple of properties. We've got the product rule, we've got the quotient rule, and we have the power rule. And what that allows us to do is we can take a single logarithm like this one and expand it out. Or we can take a really, really big logarithm and we can condense it back down, okay? And we're also going to use the change of base property. So let's do this. Let's talk about the product rule first. Let me come up here. All right, so we've got the product rule. All right, and what that means is if I have a log base b of, say, some number a times, say, c, okay, then what I can do is I can expand this out. And what I can do, the product rule states that if I'm multiplying two things inside of a logarithm, I can write that as the sum of logarithms. So log base b of a plus log base b of c. Okay, so an example, okay, of using this would be something like this. Let's say you got log base 7 of, say, 7x, okay? And let's not use 7x. Let's use, say, like 3x, okay? What I can do is I can expand this out. I can expand this out and write this as log base 7 of 3 plus log base 7 of, say, x, okay? And that's all I'm doing. Now, what we need to do is be able to go from this go from a single logarithm and expand it out, or go from a series of logarithms and write it as a single logarithm, okay? So now let's talk about the quotient rule. All right, so the quotient rule states that if I have, say, some logarithm, log base b of a divided by c, okay, then what I would do is I would write that as the difference of logarithms, okay? And so I would write log base b of a minus log base b of c, okay? And so that's what I've got, all right? And so if you are dividing two things in here, log of that minus log of your numerator minus log of your denominator, okay? So an example of this would be all right, let's say you've got log base 10 of x over 6, okay? So what I would do is I could expand that out, and I could write that as log base 10 of x minus log base 10 of 6. Okay? And that's it. Okay? All right, the next one that I've got is the power rule. Okay, and what the power rule states is that if I have, say, log base 10 of, say, x squared, okay, then what I can do is I can take this exponent and bring it out front as a multiplier, okay? Kind of a cool thing that we can do there. So what I'm going to write this as is I would write this as 2 times log base 10 of x, okay? And so that's what I've got, all right? So it's pretty much self-explanatory, and that's more of an example, not more or less a rule, but that's the idea. Okay, so what I want to do next is do an example of where I expand a logarithm, and then an example where I condense a logarithm. All right, so I'm going to come in here, and let's call this expanding a logarithm. All right. And I'm going to do the example of, let's just do log base b of, say, x cubed divided by y times z. All right. So what I have, log base b of this whole thing. Okay, so the first thing that I notice is that I've got a quantity of x cubed being divided by the quantity yz. So the first step that I'm going to do is I'm going to separate this out and write it as the difference of logs. So I've got log base b of x cubed minus log base b of y times z. Okay, and so from there what I do is I say, all right, well, I'm going to have log base b of x cubed minus the quantity. Now, because I'm multiplying these two things on the inside, okay, what I can do is I can write this as log base b of y plus log base b of z. Okay, and we can put those in parentheses. Sorry, it doesn't look very nice and neat, but that's the idea. Okay, now, I'm not done yet because I still have this 3 up here, all right? And so if I've got the 3, okay, I'm going to pull that out front as a multiplier and do log base b of x minus the quantity log base b of y plus log base b of z, okay? And that is my expanded logarithm, okay? So that's, you know, one option. All right, now let's take a look and let's look at condensing. Okay, so let's look at condensing a logarithm. So condensing a logarithm. Okay, so let's look at this example here. Let's just do, say, 1/2 times log base a of x minus 7 times log base a of y, and then plus log base a of z. All right. And what I'm going to do here is I'm going to write this as a single logarithm. Now, the first thing that I've got here is I notice that I have these multipliers out front. So I'm going to take these values and put them as exponents over those values. So this is going to be equal to log base a of x to the 1/2 power minus log base a of y to the 7th power plus log base a of z. Okay, now, what I notice here is that there aren't any parentheses. Okay, so I'm just going to work from left to right because you're kind of wondering, all right, well, do I multiply these two and then subtract? It kind of depends. If you have something in parentheses, then you would have to do that part first. So when you're condensing these down, you do have to adhere to the order of operations, okay? So let's do this. Let's simplify this part first because when we do order of operations, we work from left to right. So if I'm subtracting these two logs, that means I want to be dividing them, okay? So let's do this. Let's do, log base a of, and I'm going to do x to the 1/2 power divided by y to the 7th power. And then I'm going to add that to log base a of z, okay? So at this point, what I want to do is I want to multiply these, okay? So since I'm adding these, I want to multiply what's inside my logs. And I can put parentheses around this guy, too. All right, so then what I have here is I've got log base a of x to the 1/2 power over y to the 7th power times z, okay? Now, when I multiply these fractions together, z is over 1. Okay, so really z is going to be a part of my numerator, okay, when we simplify this. So this is going to be log base a of And I'm going to put z out front, so z times x to the 1/2 power over y to the 7th power. Now, if I've got something raised to the 1/2 power, let me rewrite this. Log base a of z. Now, something raised to the 1/2 power is really just the square root of x, and then divide that by y to the 7th. And what I have now is I have a single logarithm. Now, the way to know that if you're correct is, can you go back and forth? Can I go back in and split this up and arrive back to where I started here? Okay, that's the question. All right. So, all right, let's do change of base real quick. Okay, and the change of base is something that allows you to, evaluate a logarithm. Okay, and so remember, I think we talked about this in the last section, but let's just go over it again. What this means, so your change of base, your formula is this. So what I want to do is I want to do log base b of m, okay, would be equal to log base 10 of m divided by log base 10 of b. Okay, now when you do this, the reason why we do the change of base formula is to evaluate logarithms, okay, and to figure out what that is. And so remember, and what you want to do in your calculator, so this is what you'd put in your calculator, would be, log of m divided by log of b. All right, and so that in and of itself is just the, that's what you put in your calculator, because your calculator always is already going to do log base 10. So I write that down just because that's what we're really doing. But when you put that in the calculator, that's what you've got. So let's do an example of that. Okay, so let's say that we want to evaluate, say, log base 7 of 20. Okay. And what this means, remember, guys, that you're, what you're doing here is you're solving for an exponent. You're trying to answer the question, at 7 to the what power gives you 20, okay? And what would x be equal to? All right, that's essentially what you're doing, okay? So if you have something like this question, you can change it into a logarithm form based on what we learned in the last section, and then you can plug this in and evaluate. So what you would do in your calculator is you would just put log of 20 divided by log of 7, okay? And I'm just going to plug that directly into the calculator. And that would be approximately 1.54, or if we did 3 decimal place, 1.54 is fine. Okay, 1.54. So remember, guys, that, this is a number, okay, a number. And this is what helps us figure out what that number is, and we can use the calculator to do that. Because this is a question that you can't answer. Okay, 7 to the what power gives you 20? Well, 7 to the first power gives you 7. 7 squared gives you 49. So, the value for x has to be some number between 1 and 2. All right, and so, x would be approximately 1.54. All right. All right, so that's the idea. Hopefully this makes some decent sense to you. Let's go ahead and do the problems on this page, and then we'll do the problems on the next page, and we'll move on to the next section. Thanks a lot. Bye.